Next, we're looking at question 8.5 and question 8.6, which are a whole lot like what we've been doing, but just in case you need more practice. Let's see. So, okay, sorry. It says calculate the hydroxide solution in example 8.2. So let's go back to 8.2, example 8.2. So it says calculate the pH. Let me get out my paper. It says calculate the pH of this concentration solution of HCl. So this is example 8.5. It wants us to calculate the hydroxide ion concentration. And then it says to go back to example 8.2. In this we had a pH, and then we used that pH to get, no, it says calculate the pH, and it gives us the hydroxide, sorry, the hydronium solution, and so we stuck that into the formula and got the pH. So let's just write down the hydroxide ion concentration, the hydronium ion concentration, because we don't need the pH. So that's 1.0 times 10 to the negative third. 1.0 times 10 to the negative third molarity. So we are going to use our handy dandy ion product for water, Kw. So we know that Kw equals the hydronium ion concentration times the hydroxide ion concentration. We know that 1.0 times 10 to the negative 14 is Kw, and we know our hydroxide as our hydronium ion concentration is 1.0 times 10 to the negative third molarity. That leaves us with our hydroxide ion concentration. So we divide both sides by the hydronium. Those cancel out because anything divided by itself is just 1, and 1 times anything is just that thing. So that leaves us with hydroxide. And then we divide those two. We can stick it in the calculator as we've done in previous examples, and it should be negative 11 molarity. I always forget to add the molarity. If you're wondering how I'm doing this in my head, I'm no super genius. It's just that because these two are the same, and of course these two are the same, and because we're dividing, we say negative 14 minus a negative 3. Negative 14 minus a negative 3. Well, that's the same as negative 14 plus 3. And negative 14 plus 3 is negative 11. So that's how I'm doing that. And there we've got our answer. Now let's see if we can knock out 8.6. Basically doing the same thing, but this time for example 8.3. So let's go to 8.3. In 8.3 we had defined the hydronium ion concentration, and we found that answer to be 1.0 times 10 to the negative fourth molarity. So for example 8.6, in which we're going back, sorry, I'm getting all confused. This is question 8.5, in which we went back to an example. And this is question 8.6, in which we went back to example 8.3. Okay, so we are tasked with finding the hydroxide ion concentration, and they asked us to go back to this example, in which I looked over here and I found the answer that was the hydronium ion concentration. Same deal here, we're going to use the Kw. I don't have to do the algebra again. I know from above that hydroxide is the Kw divided by the hydronium. And so the hydroxide will be 1.0 times 10 to the negative what? 14 minus negative 4, negative 14 minus negative 4 is negative 14 plus 4 is negative 11. And there we go. Don't forget, you can slow me down by going to the lower right-hand corner in settings and adjusting the playback speed.